Okay, let's unpack this. Imagine for a second, right, that you have this brilliant idea for an app over the weekend.
Oh, like a Saturday morning making coffee kind of epiphany.
Exactly. It just pops into your head. And instead of doing what we, historically had to do,
Which is spend months learning a new programming language, wrestling with obscure syntax error.
right, watching endless tutorials until your eyes bleed. Instead of all that, you just sit back, pull out your laptop, and you just describe it to your computer using your voice.
You literally just talk to it.
Yeah. You just say it like, make me an app that does X, Y, and Z, make the buttons blue, add a database, and by Sunday night, that app is fully functional, sitting on your phone doing exactly what you imagine.
It sounds like an absolute dream, right? It
Yeah.
could be pure magic.
It does, but then I want you to imagine taking that exact same app built over a weekend by just casually chatting with your computer and relying on it for your core business infrastructure,
Right.
or like your banking.
Oh, wow. Or a hospital's patient intake system,
Yes. Suddenly, that magical dream feels like an absolute nightmare.
because it becomes a massive liability. The stakes shift completely, and, that illusion of safety that you get from a weekend prototype, it just shatters the moment real-world complexity is introduced.
And that tension right there between the magic of instant creation and the terrifying reality of relying on systems we didn't actually build, that is what we are exploring in today's deep dive.
It's such an important topic.
It really is. We have this fascinating stack of notes based on a May 2026 blog post. It's titled Netizen, The Party is Over. From vibe coding to agentic engineering, spec engineering, system engineering.
Yeah, and it's a critical piece of writing. I mean, it really captures this massive cultural and technical whiplash we've all been experiencing over the last couple of years.
Whiplash is the perfect word for it.
Because we went from thinking AI would just be like a helpful autocomplete tool to thinking it would replace engineers entirely, to now realizing something much more nuanced and honestly much more demanding is happening.
So our mission today is to take you on that exact journey. We are going to explore how AI coding has rapidly evolved from a chaotic, almost magical party trick into this highly demanding, sophisticated engineering discipline.
And what that massive shift means for how we build, how we interact with, and ultimately how we trust technology.
Exactly. So take us back to early 2025, because before the party was over, it was raging.
Oh, the wild time.
We have to talk about vibe coding.
Right. So vibe coding was a term coined by Andrej Karpathy in a social media post, I think it was February 2025, and it perfectly captures the cultural moment.
What was the core philosophy there?
It was almost anti-engineering. It was about fully giving in to the vibes, embracing these exponential technological curves, and quite literally forgetting that the code even exists.
Forgetting that the code even exists. I mean, it sounds like a meditation retreat, not software development.
Yes, exactly. Yeah.
But mechanically speaking, what did that actually look like for someone sitting at their desk in early 2025? If I'm not typing code, what am I actually doing?
The workflow was radically casual, and it relied heavily on a stack of specific tools that had just matured. So you'd use a voice-to-text tool. The source specifically mentions Super Whisper to speak your intent out loud.
So you're bypassing the keyboard entirely.
Completely.
Yeah.
You just describe what you want the app to do. Then that text goes into an LLM-powered agent. Back then, it was often Cursor Composer running on a frontier model, like Claude 3.5 Sonnet.
Right. And Cursor wasn't just, an autocomplete that finishes your sentence. It was actually reading across your entire project directory.
Precisely. It could view multiple files simultaneously. So you give it the voice prompt, and the agent takes over. It generates the code, it runs it, it hits an error, and it debugs itself.
Which is wild.
It is. And when it finishes a loop, it presents the changes to you. And here is the defining characteristic of vibe coding as a user. You aren't meticulously reviewing the diffs.
You are reading the line-by-line changes.
Right. You aren't checking to see if it used the right variables or optimized the memory. You just look at the preview window, see if the app looks right, and you just click accept.
You're just bouncing the ball back over the net. Like if a red arrow pops up on the screen, you don't even read the stack trace.
No, not at all.
You just copy and paste the error back into the chat and say, fix this.
Exactly. You treat the AI as a total black box. The source highlights a specific demonstration Karpathy did to prove this exact point. He built an app called Menugan.
Oh, I remember this.
Yeah, the idea was simple. You take a photo of a physical restaurant menu, and the app turns it into an AI-enhanced digital version with, generated images of the food.
Right.
And he built this in just a few hours. And the kicker, He did it without any prior web or Swift experience. He had never built an iOS app.
Zero experience with Swift. I mean, that is the part that completely blew people's minds. Swift is notoriously strict
Oh,
now.
very strict.
Mm.
It requires a deep understanding of state management, compiler rules, memory allocation.
And to just bypass all of that, it wasn't just faster coding for coders. It was coding for people who fundamentally didn't know how to code.
That's why it grabbed all those headlines.
Yeah, the reaction was insane. It went completely viral. I remember seeing it in the New York Times, Ars Technica. It felt like this massive cultural milestone.
Because it captured the exact moment when large language models finally became capable of coherent, multi-step workflows.
It popularized this mind-blowing idea that the hottest new programming language is just English.
It drastically raised the floor.
Mm.
Suddenly, a non-expert could build a functional prototype. It lowered the barrier to entry so significantly that the pool of potential creators expanded overnight.
You had like marketing managers building internal data dashboard.
Yeah, designers building functional web apps without ever needing to talk to a developer.
It sounds incredibly empowering,
Yeah.
democratizing software so anyone can build it. But I have to push back here. If anyone can just vibe an app into existence over a weekend with zero meticulous oversight and zero understanding of the underlying syntax, aren't we just opening the floodgates for absolute digital garbage? Like, if you don't know how the app is routing data, you're essentially driving a car blindfolded just because the engine sounds nice.
That is precisely the critique that emerged almost immediately. The source notes that while the masses were celebrating this democratization, veteran engineers and security researchers were sounding the alarm.
They saw the writing on the wall.
They did. They recognized that while vibe coding was a phenomenal tool for rapid prototyping, it was completely reckless for production. It relies on a fundamental misunderstanding of what large language models are actually doing when they generate code.
Okay, let's dig into that mechanism, because to the vibe coder, the app works. They click the button, the image loads. What is actually happening under the hood that makes it so reckless?
You get what the source brilliantly calls the hangover.
The hangover. I love that.
It's perfect. The fundamental reality is that vibes do not scale to production systems. The generated code from vibe coding tends to be bloaty, it's brittle, and it is absolutely riddled with security risks.
Let's break those down. Bloaty, brittle, insecure. I mean, I understand bloaty. The AI is probably just throwing everything at the wall to make it work, right?
Yeah, it might import an entire massive library just to use one simple function. So the file sizes are huge and totally inefficient.
But brittle. Why is an AI-generated app more brittle than a human-generated app if they both function perfectly in the prototype phase?
To understand the brittleness, we have to look at the mechanics of an LLM's context window.
Yeah,
An LLM is essentially stateless. It doesn't possess a continuous memory of your project.
right.
Every single time you send it a prompt, it has to reread the code you provided in its limited context window.
So it's like a developer who has amnesia every 5 minutes and has to quickly skim your files to remember what they were doing.
That's a great way to think about it. Now, contrast that with a human engineer. A human architect holds a mental model of how all the pieces of a system connect globally.
They see the big picture?
Exactly. If they need to add a feature, they might refactor the foundational code to gracefully support that new feature. An AI, operating in a vibe coding loop, is often just trying to solve the immediate localized prompt right in front of it.
Oh, I see. So if I tell it, make the button do X, it doesn't restructure the app to make that make sense.
It just slaps a new function on top of the old one to force the button to do X.
You're basically just slapping digital duct tape on it.
Yes, it patches things together with duct tape. It might duplicate variables, create convoluted routing paths, or write contradictory logic that just barely manages to execute.
Just to satisfy that one specific prompt.
Right. It works today, but the moment you try to add a new feature, or the moment a user interacts with it in a slightly unexpected way, the entire structure collapses.
Because it's a mess under the hood.
The context window eventually gets overwhelmed by the spaghetti code it created,
Yeah.
and the AI loses the ability to even understand its own architecture. It's a total house of cards.
If you're listening to this and you've played with Copilot or Cursor on a personal project, you have probably felt this exact moment.
Oh, absolutely.
That 2 a.m. panic when the AI rewrites a critical file, the whole app breaks. And you stare at the screen, realizing you have absolutely no idea how to revert it.
Because you didn't actually write the architecture in the first place. You have no mental model of the system.
Exactly. You're just lost in your own code base.
That is where the hangover hits hardest. Because the creator completely bypassed learning the underlying syntax, they have absolutely no deep understanding of the architecture.
You're staring at a wall of broken, highly complex code.
And your only recourse is to paste the error back into the AI and hope it fixes it.
Mm.
But because the code is so tangled at that point, the AI's fix usually just breaks something else.
It's a vicious cycle. So what does this all mean for the software industry? I mean, the fun stops the second you have to ship to real users.
Because real users are chaotic.
Right. They do bizarre things that create edge cases you never thought of, and then you have to deal with strict industry regulations, data privacy laws, maintaining the software over a timeline of years, not just a weekend.
Vibe coding raises the floor, making it easy to start. But professional software demands preserving or even exceeding prior quality bars. The party is officially over when you have to maintain a system that handles people's data securely.
You can't just vibe your way through a SOC2 compliance audit.
No, you definitely cannot.
But professional developers didn't just look at this incredible tool and say, nah, too risky, we'll go back to typing everything by hand. The productivity gains are just too massive to ignore.
Far too massive.
So how did the discipline evolve to harness the speed without the hangover?
They move toward rigor. And this brings us to the successor of vibe coding, which was popularized around early 2026, agentic engineering.
Agentic engineering. It sounds much more systematic.
It is entirely about structure and discipline. Agentic engineering isn't about letting a single AI agent do everything while you sit back and catch the vibes. It's about orchestrating fleets of highly specialized agents.
Fleets of them.
Yeah. You have one agent designed specifically for planning architecture, another agent that only writes front-end code, another that only runs security tests, and another that acts as a debugger.
It's like an entire virtual development studio.
Exactly. And the source uses this incredibly vivid analogy to explain the human's role in this setup, the opera conductor.
Oh, I love this analogy. Let's get into it.
An opera conductor stands at the podium. They don't play the cello. They don't play the flute. They aren't producing the raw notes, just like the agentic engineer is no longer typing the raw syntax.
Right.
But the conductor is shaping the entire performance. They provide precise direction, they cue different sections at the right time, and they bring in deep, holistic knowledge of the entire symphony's structure.
They know how it's all supposed to sound together.
Right. In agentic engineering, humans retain full responsibility for the architecture, the trade-offs, the ultimate goals, and the final judgment. The agents just handle the raw execution at scale.
The conductor analogy is fantastic for visualizing the role, but I have a major concern here.
What's that?
If I'm conducting the London Symphony Orchestra, I'm directing seasoned professionals who have been playing their instruments for 40 years. If I point to the cellist, I know they're going to play a perfect C note.
Right.
But if these agents are the musicians, they aren't seasoned professionals. They're more like wildly enthusiastic, highly caffeinated interns.
Yes.
What happens if the violinist agent goes completely rogue and starts playing jazz in the middle of a classical symphony? Or worse, silently hallucinates a security vulnerability?
That is the core vulnerability of the system, and it introduces a mandatory practice within agentic engineering called suspicious oversight.
Suspicious oversight.
You hit the nail on the head by calling them interns. The source explicitly states that these agents must be treated as capable but deeply fallible interns.
Right.
They have incredible, almost superhuman recall of information. I mean, they have read every piece of documentation on the internet, but they have incredibly weak judgment.
High recall, weak judgment. That is a terrifying combination if left unsupervised.
Very terrifying.
It means they will confidently provide a highly detailed, perfectly formatted answer that is fundamentally wrong.
Exactly. That is why suspicious oversight is non-negotiable. You have to assume that the outputs need rigorous verification. You cannot outsource understanding.
That's a great way to put it.
You can outsource the typing, you can outsource the heavy lifting of the execution, but you can only direct what you deeply comprehend. The source uses a brilliant, almost haunting phrase to describe how we should view LLMs. We must treat them as jagged statistical ghosts, not motivated animals.
Jagged statistical ghost. Okay, wait, stop right there, because we really need to unpack that phrase.
It's a haunting way to put it, right?
It really is. So let's start with jagged. Because I usually, I think of AI competence as this smooth curve, you know? Like, if it can write a complex Python backend, I assume it also knows basic logic. What do you mean by jagged?
Jagged refers to the highly uneven nature of their competence frontier. A human expert generally has a smooth curve. If an accountant can do complex corporate taxes, you can safely assume they know how to do basic addition.
Right, it's foundational.
But an LLM doesn't learn like a human. It predicts tokens based on statistical distribution in its training data, so its competence is jagged.
It has blind spots.
Massive ones. It might perfectly write a state-of-the-art encryption algorithm in one breath, and in the next, completely fail to count the number of R's in the word strawberry.
Because it's not actually thinking about the math, it's just predicting the next most likely chunk of text.
Exactly. And that brings us to the ghosts part of the phrase. There is no ghost in the machine. There is no intent.
No internal monologue.
Right. There is no motivated animal inside the computer trying to solve your problem or protect your system. It's just a statistical engine predicting the next token.
So if you project human motivation onto it, if you treat it like a colleague who understands the meaning and the stakes of the task, you're going to get burned.
You will be unpleasantly surprised when it drifts off course and introduces a critical vulnerability simply because that vulnerability was statistically common in its training data.
Wow. So the human is the only entity in the room with actual comprehension. The human holds the why, the machine holds the what.
Exactly.
And this fundamental shift from typing explicit code to managing the context and overseeing these statistical ghosts, this is what Karpathy was talking about in his Sequoia talk when he framed this era as the dawn of software 3.0, right?
Yes, precisely. To
Yeah.
truly grasp the magnitude of software 3.0, we have to look at the progression.
Let's do it.
Software 1.0 was traditional explicit code. A human engineer typed every single logical step. If X happens, do Y, allocate this memory, run this loop. The human was the compiler of logic.
Very deterministic, very manual.
Right. Then came Software 2.0, which was the era of neural networks and deep learning. Instead of writing explicit rules, humans gathered massive data sets, defined an architecture, and trained weights.
So the system learned the logic from the data itself?
Exactly. Think of early image recognition or recommendation algorithms.
Okay, so what makes software 3.0 fundamentally different from that?
In Software 3.0, the neural networks, the LLMs, are already trained. You aren't gathering data to train them. The primary lever of control is no longer writing rules or gathering data sets. It is prompting and context.
Ah.
You are using natural language and carefully curated context windows as the ultimate lever over the LLM interpreter. You are programming the behavior of the model using English, system prompts, and tool access.
But if our primary tool for building complex systems relies on English prompts fed to a jagged statistical ghost, how do we ever trust the output?
That is the million-dollar question.
I mean, how do we build something as robust as a banking app or an airline scheduling system if the core engine is just predicting text?
The massive unlock for the Software 3.0 era, the thing that makes it actually viable for engineering, is a concept called verifiability.
Verifiability.
What's fascinating here is that LLMs are not universally great at everything. If you ask an LLM to write a persuasive essay, grading it is totally subjective. There's no right answer.
Right, it's just vibes.
But they are exceptionally powerful in domains where humans can definitively and automatically check their work.
Domains where there is an objective ground truth, like math.
Math and, crucially, code. In these verifiable domains, there is a clear right and wrong. If an agent writes a piece of code, we don't have to just trust it. We can run it through a compiler.
We can execute unit tests.
We can mathematically prove if the function returns the expected result. And because the environment is verifiable, the LLMs can actually improve themselves via reinforcement learning.
Wait, explain how that works in practice. How does an agent use a verifiable environment to get better on the fly?
Okay, imagine an agent is tasked with writing a sorting algorithm. It writes the code and attempts to run it. The compiler throws a syntax error.
It fails.
Right. But because the environment is verifiable, the agent can feed that exact error back into its own context window, realize its mistake, and rewrite the code.
Oh, wow.
It can try, fail, get an explicit error, and try again in a closed loop until the test passes perfectly.
Ah, I see. So because the output of software development is inherently verifiable, it either compiles and passes the tests, or it doesn't. The bottleneck of the whole industry shifts.
It shifts entirely.
The hard part is no longer sitting there typing the syntax because the agents can iterate against the compiler 1,000 times a minute. So what is the hard part now? How does the day-to-day workflow of a software engineer actually look in Software 3.0?
The workflow becomes heavily architectural and managerial. You are spending your time decomposing massive high-level goals into smaller, discrete tasks.
You're breaking down the problem.
Yes. You are assigning those tasks two specialized agents. But most importantly, you are defining the verification parameters. You are writing the tests.
Setting the boundaries of the sandbox.
Exactly. It relies heavily on human-in-the-loop protocols, or HITL. It requires strict evaluations, continuous audits, and robust rollback capabilities for when the agents inevitably hallucinate.
You're making sure they can play safely. But think about this, if we aren't writing code anymore, and the entire bottleneck is just giving these agents the right instructions and checking their work, then the instructions themselves must have to be incredibly rigorous.
Oh, beyond rigorous.
You can't just say, make a secure login page.
No, and you've just identified the next major evolution in this journey. Because the instruction is the only thing guiding the agent, the instruction itself becomes the most critical piece of engineering.
All right.
We enter the era of spec engineering.
Spec engineering, meaning specification.
Precisely. In the old Software 1.0 days, a specification was often just a brainstorming document. It was a Word file, a Jira ticket, or a whiteboard sketch that product managers handed to engineers.
Just a rough idea of what we want.
It was a loose guide, and the human engineers filled in all the logical gaps using their own common sense and experience.
Because humans know what a login page should generally look like.
Right. But in the agentic world, the specification isn't just a guide. It literally is the program.
The spec is the program, because the AI is reading that document and generating the entire application directly from it.
Exactly.
So if the spec has a logical gap, the AI doesn't use common sense to fill it. It just creates a bug.
It will do exactly what you wrote, flaws and all. If the spec is bad, the app is bad. If the spec is perfect, the app works.
That is a crazy amount of pressure on the spec. So what actually goes into a modern Software 3.0 spec?
It is a highly formalized, deeply technical document. A modern spec must rigorously encode human intent. It has to outline rigid constraints. It must define the edge cases mathematically.
Like what?
Like, what happens if a user inputs a negative number where a positive one should be? How does the system handle a network timeout during a transaction?
You have to spell out everything.
Everything. It has to establish the entire security posture. And crucially, it must define the success criteria at a level so precise that agents can reliably execute it, and automated testing suites can reliably verify it.
This sounds incredibly difficult. It's like writing a constitutional law where every single loophole must be closed, rather than just sketching a treehouse.
That's a great comparison.
Writing a document that is rigid enough for a computer to execute without ambiguity, but abstract enough to capture complex human intent. Can't just have one standard programmer sitting in a darkroom doing this, right?
No, absolutely not. The source mentions this requires an entirely new kind of cross-functional team to reinvent major industries.
Let's talk about that team.
Right. So if you want to reinvent a massive sector, let's say you want to build a new agentic healthcare intake system, you need a deeply diverse group. You need domain experts for the nitty-gritty details.
Like a doctor.
A doctor or a compliance officer who understands exactly how HIPAA regulations mandate patient data must be encrypted and handled at rest.
Because the AI doesn't intuitively know HIPAA compliance, you have to specify it explicitly in the document.
Yeah, exactly. But you also need imaginative thinkers who can spot novel Software 3.0 architectures. Because you aren't just rebuilding old apps faster, you can build things that were previously impossible.
Give me an example of that. What does a Software 3.0 architecture look like? How is it fundamentally different from a regular app on my phone today?
The source gives two fantastic examples, LLM-generated dynamic wikis or diffusion-rendered user interfaces.
Diffusion-rendered UIs.
Let's look at the UI. In Software 1.0, a human designer created a static screen for every possible state of the app. You had a home screen, a settings screen, a profile screen.
They drew every box and button.
Right. But in Software 3.0, imagine an app that doesn't have static screens. Instead, it generates a custom temporary interface on the fly based on exactly what the user needs in that specific millisecond using AI image generation and dynamic text routing.
Wait, so it literally just invents a custom dashboard on the spot?
Right then and there. It renders exactly what you need.
So if I ask my banking app to compare my grocery spending to last month, it doesn't navigate me to a pre-built chart. It literally invents a custom dashboard with exactly those two metrics, renders it on my screen, and then discards the UI when I close it.
Exactly. The UI is completely fluid.
That is mind-bending.
It is. So you need the domain expert to handle the banking regulations, the visionary thinker to conceptualize that fluid UI, and product experts to ensure it actually feels good for a human to use.
Right, because if it's too weird, people won't use it.
Exactly. And finally, you need the spec engineers to take all these ideas and translate them into a living governance document that the agents can reliably parse and execute.
Here's where it gets really interesting to me. We used to think of software development as a purely mathematical and logical pursuit. The realm of the solitary coder in a hoodie.
The classic stereotype.
Right. But now, to build incredible software, you need philosophers, doctors, domain experts, and visionaries all coming together to craft this living governance document.
Living governance is the perfect term because a Software 3.0 spec is never truly finished. It evolves.
Because the world changes.
Exactly. As the business needs change, the domain experts refine the text in the spec, and the agentic engineers, the conductors, oversee the agents as they rewrite the code base to match the new spec.
So mechanically, how do these specs interface with the tools? I mean, I'm imagining this massive Google Doc, but how does the AI actually ingest that?
The tooling is evolving rapidly to support this. The source mentions how tools rely on things like annotated markdown specs.
Markdown, like the text formatting language.
Yes, it's lightweight. You write your highly detailed, structured requirements in Markdown with specific tags and annotations that the agentic orchestration tools recognize. You essentially compile this text document directly to complex tech stacks.
So I write a highly detailed text document, verify all the logic, hit a button, and the orchestration platform just spins up the database, writes the backend, deploys the front end, and runs the tests.
That's the goal.
It's the difference between sketching a treehouse on a napkin and handing mathematically perfect blueprints for a skyscraper to an automated construction crew.
You better make sure those blueprints are perfect.
That's seriously. And that contrast is exactly why the era of vibe coding had to end, right?
It had to. Vibe coding skips the spec entirely. You go straight from thought to code.
And what happens? You get agent drift, unverifiable messes, massive security holes.
But rigorous spec engineering. That is what unlocks the stratospheric ceiling of reliable leverage for professional teams. It allows a team of 5 people to build a system that used to require 500.
Which naturally brings up the biggest question of all.
What's that?
If we figure out how to write perfect specs, and we figure out how to conduct fleets of agents to build reliable, massive software systems, what happens to the world around us?
The macro impact.
Exactly. How do our human organizations actually handle this level of automation and speed? And that brings us to the highest level discussed in the source material, system engineering.
System engineering is the macro view. It's about taking this incredible, almost overwhelming technology and integrating it with human institutions, human culture, and human incentives.
Because you can't just drop an army of autonomous AI agents into a traditional 2020s corporate structure and expect things to go smoothly.
The friction would be catastrophic.
Because traditional corporate structures are built around human limitations. We have meetings, we have email chains, we have weeks of deliberation because humans take time to process information.
But AI agents process information in milliseconds.
Right. So the source details massive infrastructure changes that are happening at the enterprise level in 2026 to accommodate this speed. We are moving toward entire digital ecosystems built natively for agents, not humans.
Yes, agent-native ecosystems.
Let's get into the mechanics of that. What does an agent-native ecosystem actually look like inside a company?
It requires several new foundational layers. First, it requires context lakes.
Context lakes?
Think of a context lake as a massive, continuously updated repository of company knowledge. Every Slack message, every code base, every financial report, every spec document.
Wow.
But specifically formatted and indexed, not for a human to search, but for LLMs to draw from instantly. It acts as the shared short-term memory, or RAM, for all the agents in the company.
So an agent doesn't have to, ask a human for a file or wait for an email reply. It just pulls directly from the context lake.
Instantly. What else do you need? You also need agent registries.
Registries? Why?
Because if you have thousands of autonomous programs executing tasks, a company needs an immutable ledger of exactly which digital entity is doing what permissions they have, and who the human overseer is.
Okay, that makes sense. Accountability.
Exactly. And of course, you need robust human-in-the-loop protocols built directly into the corporate hierarchy, so that critical decisions like authorizing a massive payment or changing a core security policy automatically pause and route to a human for approval.
So instead of an organizational chart consisting purely of human employees, you have an org chart of humans Fleets of specialized agents reporting to those humans, and infrastructure designed specifically for the agents to read and interact with.
It's a completely new paradigm.
That is wild to think about inside a single company. But the source explores a concept that I think is even more profound, the idea of my agent talks to your agent.
Oh, the interagent economy.
I want to dig into this. What happens when your AI needs to interact with another company's AI?
This is a fundamental shift in global commerce. Let's look at a concrete example, like a supply chain scenario. Imagine you run a manufacturing company. Your internal supply chain agent detects a shortage of a critical raw material, say industrial copper.
Okay.
In the past, it would flag a human who would then email vendors, negotiate prices, and sign a contract.
A process that takes days or weeks.
Right. In a system-engineered world, your supply chain agent identifies a vendor and contacts their sales agent directly.
But they aren't sending emails for humans to read, right?
No, they are communicating via agent-native APIs. Application programming interfaces designed specifically for AI-to-AI communication.
So there's no human-readable interface at all.
None. It is just raw data and logic being exchanged. But it's not just a simple data transfer like we've had for decades. Your agent actually has to negotiate the price dynamically based on your budget spec.
They're haggling.
They are haggling. It has to establish trust and verify the vendor's credentials. It has to execute a smart contract for payment and confirm delivery schedules.
And all of this happens autonomously, machine to machine, in milliseconds.
Yes.
The speed of business becomes literal light speed. It's almost incomprehensible. But if everything is moving that fast and the execution of business logic is heavily reliant on these agents and specs, how does this violently shift the hiring landscape?
It changes everything.
I have to imagine companies are looking for completely different skills now. The old playbook of how to get a tech job must be obsolete.
The shift is violent and absolute. The source points out that companies no longer care if you can stand at a whiteboard and solve a LeetCode code puzzle.
Right. The classic tech interview is dead.
They don't need humans who can memorize sorting algorithms or manually invert a binary tree. The machines do that instantly and flawlessly in a verifiable environment.
So if I'm an engineer walking into an interview in 2026, what are they actually testing me for?
We want to test your orchestration and your spec skills on massive projects. An interview today looks like this. Here is access to a fleet of specialized agents. We need you to build a secure, verifiable, HIPAA-compliant clone of this complex data platform, and we need the architecture mapped and the first functional prototype by tomorrow.
Tomorrow.
Yes. They are testing your ability to be the conductor.
They are testing my ability to write the living governance document. Can I decompose the problem? Can I exercise suspicious oversight to catch the jagged statistical ghosts when they inevitably hallucinate a security flaw?
Exactly. It's testing your taste, your systemic judgment, and your rigor. It's a much higher level cognitive skill than typing syntax.
It's like moving from being a bricklayer to the city planner.
That's exactly it. And it's not just individuals who have to adapt. The source notes that massive institutions and regulators are being forced to adapt to these agent-native realities.
What does an agent-native regulation even look like? How does the government regulate a ghost?
Well, it means that legal and compliance documents might need to be published in formats optimized specifically for AI parsing, not just human lawyers.
Oh, interesting.
And it means redefining legal liability at a foundational level. Let's say your procurement agent hallucinates, misinterprets a spec, and executes a multi-million-dollar trading error with another company's agent.
A flash crash caused by an AI negotiation.
Right. Who is legally liable? The human who wrote the original markdown spec. The agentic engineer who is supposed to be in the loop but approved it too quickly. The company that created the base LLM model.
It's an absolute legal minefield. The law moves at the speed of paper, but commerce is now moving at the speed of inference.
Exactly.
Institutions are going to have to scramble to define legal liability for human oversight in a world where the execution is completely autonomous.
It's going to be messy. But stepping back from the anxiety of all these massive societal shifts, the expert analysis in this source really grounds the entire conversation with one profound takeaway.
What's that?
It states that at its core, we are essentially automating information processing itself. But, and this is the critical, but understanding remains strictly human.
We are automating the processing, but not the comprehension.
That is the anchor of this entire technological wave. Agents amplify us. They give us unprecedented, almost godlike leverage over information.
They can read 1 million pages of case law in a second.
Yes, they can write 10,000 lines of verifiable code in a minute. But they do not replace human judgment. They do not have taste. They do not understand the ethical implications of the systems they are building. And crucially, they cannot hold accountability.
If the system crashes, the AI doesn't go to jail.
Exactly.
The AI doesn't lose its reputation. The human conductor does. We can outsource the heavy lifting, we can outsource the typing, but we cannot outsource the ultimate responsibility of comprehension.
The ceiling for what we can achieve as individuals and small teams has never been higher. A single person can now build what used to take a corporation.
It's incredible.
But that ceiling is reserved strictly for those who bring immense discipline, relentless curiosity, and deep humanity to the process of engineering.
What an incredible journey we've covered today. I mean, we started by looking at the sheer democratization and chaotic, liberating fun of vibe coding in early 2025.
The party days.
The party days. It was a moment that raised the floor where anyone could bypass the keyboard, speak an app into existence, and feel that magic. But then we moved through the painful but crucial hangover, the realization that vibes simply don't scale.
They really don't.
That AI context windows decay, and brittle, stateless code collapses under the weight of real-world complexity. And finally, we arrived at the rigorous, multidisciplinary future of agentic, spec, and system engineering, where the ceiling is raised to the stratosphere for the disciplined conductors of this new world.
It really is a profound paradigm shift. It is a transition from playing with a magical toy wand to standing at a podium and conducting a massive global digital symphony.
And so I want to ask you, the listener, to reflect on your own work, your own learning, and your own day-to-day interactions with technology. When you use these tools, whether it's writing an email, analyzing a spreadsheet, or building software, are you treating the AI as a magic wand?
Are you just catching vibes?
Exactly. Are you just typing in vague prompts and hoping these jagged statistical ghosts will do the heavy lifting for you, completely unsupervised? Or are you stepping up to the podium? Are you becoming the conductor, treating them as incredibly fast, capable interns that desperately need your clear direction, your mathematically precise specifications, and your undeniable human taste?
It really is the defining question of the next decade of professional life. How you answer that will dictate your leverage in this new economy.
It truly is. And as we leave you today, I want to leave you with one final, lingering thought to mull over. A thought that builds on this wild concept of inter-agent communication we just talked about.
Right, the machine-to-machine economy.
Yes. If we are truly entering a world where my agent talks to your agent to negotiate tasks, to handle payments, and to establish trust at the speed of light using agent-native APIs, how long until we realize we need entirely new legal and economic systems designed not for humans, but specifically for resolving complex disputes between purely digital entities acting on our behalf?
That is a fascinating and I think inevitable frontier we're rushing toward.
Something to think about the next time you casually ask your computer to build you an app over the weekend. Thanks for taking this deep dive with us.